Hello everyone. So this is the third experiment of your lab. Um, as you could see, let me first find the object over here. Okay. As these experiments are, all the experiments are being performed in the dark room. So we don't have light. We are rather dependent upon this light of the lamp. In fact, whenever we need to read or write something or check the readings, etc. over here, we need to use this lamp. Okay, so I'm just using that to see what is the object. Okay, it says to determine the wavelength of light of three different colors using plane transmission diffraction grating. What apparatus do we need? We need a spectrometer. Here it is. A mercury vapor lamp. You could see actually lamp, it's giving you some light source. So this is the mercury lamp, and a plane transmission grating. Here is the plane transmission grating. As you could see, this is the grating which is placed on it. Okay, a reading lens and a lamp. Here is the lamp as I already showed to you, and a reading lens. Well, let's see, where is the lens? Lens must be somewhere here. Right, lens is missing. Okay, anyway, no worries, you will have it. Okay, so what we need to do over here, we, as you had read, that we need to find the wavelengths of the three different colors of light that the grating will fragment into, right? You know, this plane transmission grating will fragment the light into different colors, and you need to add different orders, in fact, and you need to use those orders and different colors and find the wavelength. So first of all, we need to do make the optical plane, as we do in all the experiments. To do that, we need to adjust our spectrometer and the telescope to see the direct image. Okay, so this is a rough guess. We need to in fact place it in such way, and we need to of course make this source narrow over here. Okay, the collimator. So if this is narrow, then you will see very intense the image into the telescope. Okay, so that could be seen into it. You will see actually a white light, vertical white light. That's what actually you should be able to obtain, and that means that at least the source and everything is actually sort of in the optical plane. The second thing is that we need to find, of course, the least count of this spectrometer, right? So how would you find the least count? Well, you could see actually inside it we have two scales. One is the main scale, which is bottom scale, and then you could see actually something called BER. This is the vernier scale. Okay, let me hold my camera properly. Okay, you could see. So if I move it, you could see the readings are changing, right? So let's see. The vernier scale had got 60 divisions, as you could clearly see. So these 60 divisions these 60 division equals to, and in the main scale I have half degree division. Each division has half degree. So half degree is sort of divided into 60. That means its least count is 1 over 0.5 upon 60, right? So this is the least count. You need to be using it everywhere you require, whenever you take the reading of different orders. So first of all, we need to make the normal arrangement, and in order to do that, first we need to place the grating. As you could see, I had placed it anywhere onto the table. then I should obtain a direct image over here. As I said, it is going to be a white light vertically upward, okay. And after that, what we will do, we need to make a normal arrangement. So what we should do, if we move actually this at approximately 90 degree, we shouldn't see any light. Now what we will do, we will place it at 45 degree, right? And okay, so we will keep moving actually this until the 45 degrees achieved. So what will happen there? The light from the source will come at 45 degree, then it will get sort of reflected and will come into this. So this will happen only when the angle is exactly 90 degree, okay. So once that is obtained, now what you do, go exactly at 90 degree from there by checking the readings. So that will make actually the normal arrangement, and you will know actually how to place this prism. So once this is obtained, what we need to do, we need to keep moving this way, okay. And after some time, when you move after certain degrees, you will start seeing the light of various colors into this telescope, okay. You will in fact be observing the whole visible spectrum, not whole, in fact, as 3 or 4 colors should be visible. So right, so what you need to do, and if you move little bit further, you will be able to see that that pattern actually, that those 3 or 4 5 colors which are visible, after that you will see actually a clear dark, and as you keep moving, and after certain degrees you will again see the repetition of pattern of the same colors, but this time this is sort of blurred. So the first one is called the first order pattern, and this is the second order, okay. So what you need to do, you need to place these your cross wire or telescope, using the telescope on, set actually the telescope on each of these colors and record their angular positions. That's it, okay. So we will have the direct image, take the position of that, okay. So this is the direct image, take the position of that. Now let me in fact show you the table, so, and the formula in fact that we will be using, so then the story will be more clearer. So here is the formula. I hope you could see lambda is E plus D sine theta upon n. E plus D is the grating element, as you could see. Theta is the angle of diffraction for the given spectral line in the order n. N is the order, E plus D is the grating element, and theta is the angle of diffraction for different colors. That is what you need to measure. E plus D is the grating element that you will always see actually on the grating itself. So it says how many lines it has. Depending upon those lines, grating elements would be different. So I think the one which we are using perhaps have 15,000 lines, but anyway I will check that and record it for you. So all right, I had already told you the procedure and everything. Let me directly go to the reading the table. So you could see measurement of the normal incident setting of the grating. That is the first table. As I said, this was the normal incident. I had to actually place the prism, move the 90 degree, place the prism at about 45, check actually where we see image. Okay, then we move 90 degree back. That would be the normal incidence case. Okay, this is where we need to record the reading of our verniers. But before that, in fact, it is better if you place it at 0, 0. That is what you could do by means of actually these screws over here. Okay, so let me go to the first table. So this is the direct image thing. Main scale reading, vernier scale reading, total reading. Okay, rotate the telescope to 90 plus position as I just did. Okay, and then return back. That should again give you MSR BSR total reading. Take the average, and that will give you the normal scale. After that, what we did, as I said, you will have to move this telescope. Okay, and so this is the telescope motion. and then you will see first order. Of course, you will have the colors at different locations. So move your telescope and record its readings. If you move the telescope, you will see actually the change of readings into these scales. They are on both sides, as you could see, okay? Here as well as here. So this is left and this is right. So you need to record reading on the both sides, okay? So left scale, main scale reading, vernier scale reading, total reading. Let me read one reading for you. So here, for example, it says, this is 329 degree, and then let me see the read divisions on the main scale, vernier scale. This is 30, 32, 34. So I have main scale reading 329 and the vernier scale is 34. So total reading would be 329 into 34 divided by 120. That's going to be my total reading. Okay, so this way, this is the left side reading. I will do the right hand side reading. You see these two scales over here and there. Okay, so that would be left and right side, then the difference. Okay, that's for blue, then green, then yellow. Okay, again B1, B1, B2. B1, B2 are the readings, and then you need to in fact move to the right hand side. So this is the left hand side, B1, B2. These are two scales. Then you need to move it actually right hand side. That is, you need to return back and take the readings again on the B1 and B2. Okay, so that will give you the 2 theta difference. From there you could obtain the value of theta, and after that you could take the sine theta, multiply this with E plus D, that is the grating element, divide by the order. This is the first order. Similarly, you repeat the place actually the telescope at the telescope crossbar at green. Again record the reading in the 2 verniers on the left hand side as well as on the right side. Take the difference, calculate theta and sine theta, multiply it with the grating element and divide by the order. Similar thing you could do for the yellow, and then again move the telescope, come to the second order, do the 3 colors, measure the values of theta again for MSR, BSR total reading, and thetas for all of them, sine theta ultimately, and this time, as you know, the order is 2, so therefore you should be dividing by 2. Grating element is of course the same. So this way you should be able to record all these readings, perform the calculations as are shown over here, and then record all the readings and check actually what are the standard values. In fact, looks like we have noted the values for you, the lambda standard for various colors, and find out in fact the percentage error as well and record into your practical notebook. So this completes the third experiment. Thanks.